Okay, now let's move on to question 2. We're going to do the same thing we did in question 1, and the same thing you're going to do for every question. You're going to list your variables first, okay? We know we're dealing with pressure, temperature, and volume. Pressure, temperature, and volume. We've got P1, P2, T1, V2, V1, T2, V2, right? So I'm just going to put 1 and 2 over the corners, right? Let's read through the question together. Cylinder with a movable piston contains a sample of gas having a volume of 6 liters. That's my starting volume. Okay, it's at 293 K, and my pressure is 1 atmosphere. Okay, now we've changed to atmospheres. What's the volume of the sample? There's my question word. What is the volume of the sample? So I don't know V2. I don't know what it is. I'm going to solve for it. I'm going to make sure that variable stays in my equation through all my algebra work. Okay, after the gas is heated to 303 Kelvin, okay, and somehow impossibly the pressure is held constant at 1 atmosphere. I don't know how you would do that, but let's just pretend that you can do that. Okay, so I mean, theoretically, right, if we raise the temperature, the pressure should go up also. But I guess if you have some way of manipulating the air pressure in some sort of laboratory device, I don't know. So we're going to go ahead and set this up because we now have all of our variables. We're also going to cross this out because we know that this pressure is not changing. So I don't want to plug, I mean, it's okay if you do because it's just a 1 and it's not going to change your math, but it's really a waste of time. I'm going to do all my steps one more time, right? I'm going to write out my formula. Okay, I'm going to acknowledge that I'm leaving out pressure. Once I take pressure out of the equation, I basically have Charles' law. I'm going to go ahead and substitute in. So volume 1, 6 liters. No times because it's over. Temperature 1, 293 K equals. Now I've got two fractions set equal to each other. So this is when it becomes possible for you to go ahead and cross multiply. Okay, so volume 2, I don't know volume 2. It's my x. And then 303 Kelvin. Okay, so it's a little hard to get x by itself when there's nothing else over here for you to remind you. So I'm going to just erase the volume. I'm going to leave it as an x just to make it easier to follow the algebra. Okay, I'm going to go ahead and cross multiply. So depending on which side you would like your x to be on, you might want to start on that side. Okay, so this has to be orderly. And by orderly, I want this to be orderly like a crystalline solid, okay, people? Right? When you do it, you want to make sure that the first thing you cross multiply, you write on the right, and then the second thing you cross multiply, you write on the left, and then you put an equal sign in between. And that's not because I'm being like a pain in the ass. It's because I want you to remember how to keep track of your work. Where's your equal sign? Where's your variable? Because a lot of you are making algebra mistakes because you've lost track of your work. And what I mean when I say lost track of your work, like you just wrote everywhere and you don't know what you're looking at. Like a lot of times, if you write things in a very systematic way, when you look at it, you'll right away be like, oh, okay, now I just have to divide both sides by whatever, right? So if I want my x to be on the left, I'll do this one first. So I'm going to go this way. Whatever this is times this, I'm going to put it here. So this is 293 Kelvin x times x, basically, equals. Then I'm going to do 6 times 303. It's going to get me a big number, 18 something. I don't know what it is with my getting 18 for everything when I do these calculations. So 6 times 303. I get 18. Okay, so I get 18. And my units are also multiplied here, liters times Kelvin. Okay, now I want x by itself. So that means that I have to move everybody who's on this side over there and leave X all by himself. Okay. Oh, look, I have to be all by myself. I'm so sad. Okay. You're going to divide both sides by 293. Okay, and you don't have to leave your units on, but I'm glad that people were paying such close attention to it that they were and that they were worrying about it. It's actually very, very important, your units. Okay, so now you notice that you only have liters left. Okay, 293 and Kelvin canceled out. So here I have X equals 18, 18, 293. I think we got like 6.1 liters for this. Is that what everybody got? I'm just going to plug it into the calculator quick. 18 divided by 293. 6.2. All right, it's 6.2. Again, important that you don't round. Okay, because you started off at 6 liters and your new volume is 6.2. It's not surprising that your volume has only increased by 0.2 because your temperature change wasn't that drastic. It was like 9 Kelvin, which is like about 9 degrees Celsius. So that's not a huge, you're not going to get a huge amount of expansion on a gas for, less than 10 degrees. So not surprising. All right, so that's how you get that one. Okay, go to the next video if you're done.